Dear students, welcome back to Discrete Mathematical Structure. Myself, Professor Subramanya Bhagavat, your Computer Science Coordinator. Last class we studied about, graphs. There we studied graphs, examples, subgraphs, isomorphism, we studied. This class we continue the things like walk. This class I am going to explain you about walk, circuits, open walk, closed walk, all those things we'll study. Trees also will start. What is a walk? Take a 2 minutes, 2 second time and think what is a walk. Yes, general word it is walk. We say many times like we walk on the road. Am I right? Same way we will walk here walk on the graph. How do we walk on the graph? If we take example, I am starting from vertex A and I am reaching vertex D. So that I am making a walk. I am making a walking on the road. This is a walk. A to B and B to D is a walk. So walk is nothing but vertices and edges. Alternately, if you are writing vertices sequentially, one vertex, one edge, one vertex, one edge. If you are writing, then that is called a walk on a graph. A GBA graph having at least one edge. If one edge is there, I can make a walk. Consider alternative sequence of vertices and edges. Alternative sequences of vertices and edges. In the form should be like this. First starts from one vertex, one edge. Then one vertex, another edge. Then one other vertex, another edge. That is called walk. That's called walk. Observe this, carefully observe this. I write like this. I want to start walking in a graph starts from V1 vertex and I want to reach V6. How I can walk? That's the question. You know, walk is nothing but sequence of vertices and edges one after the other. One vertex, one edge. One vertex, another edge. Starts from which vertex? V1, V1, okay. Then edge E1 and reach to the vertex V2. Am I correct? Then one edge E2 reach to the vertex V3. Then edge E8 reach to the vertex V5. Wait, V5. So this is nothing but a walk. Walk is nothing but vertices and edges you are writing. Sequence. Sequence is very important. So suppose I want to start writing like this. V1 edge E4 and it will reach V5. So this is nothing but a walk. Walk is nothing but group of vertices and edges you are writing one after another, one after other. So that is called walk. Walk may be a open walk or closed walk. Open walk is nothing but sequence of vertices and edges one after other. Where open walk and closed walk differences I will tell you. Closed walk first I will tell you. A walk that begins and ends at the same vertex is called closed walk. Terminal vertices are same. Where we started journey and reaching the same destination, that is called closed walk. Where open walk means nothing but a walk that begins and ends with the different vertices is called open walk. Terminal vertices are different here or not same in open walk. Where in closed walk, walk that begins and ends with the same vertex is called closed walk. And terminal vertices are same actually. If you observe this graph, wait, so that concept will be very clear to you. Okay, wait. If you observe here, wait. If you observe this very carefully, I am starting a journey from V1 and I am reaching a V6. V1 to V2 through EM and E2 to V3 and V3 to V6. I am writing V1 vertex H, V1 E1, then vertex H, V2 E2, then vertex V3 and H. Okay, so like this way I am reaching a V5, so that it is nothing but open vertex. This thing starting vertex and ending vertices are different. Then it is called open walk. Starts from here, journey ends here. Starts from V1 vertex, ends with V6 vertex. It's a open walk. Open walk on a graph. Where closed walk means starting, wait, observe this very clearly. If you make a, yeah, this starting vertex and end vertexes are same, then it is called closed walk. I starts from V1 to V2, V2 to V5, V5 to again V1. This is called closed walk because vertex V1 to E1 journey started, then V2 to E3, then V5 to, yeah, V5 to E4 to same V1. Starting and ending vertices are same. Starting and ending vertices are same. Then this is called closed graph. Okay, closed walk. Where please try to observe that, try to analyze it very clearly. Walk that begins and ends with the different vertices are called open walk, where terminal vertices are different. Where walk that begins and ends with the same vertex is called closed walk. Here, what we studied here, this is a closed walk because end vertices are same. Journey starts from the same vertex and ends with the same vertex. That's called closed walk. Now, next one is a trial and circuit. What is trial and circuit? Carefully watch. If an open walk, no edge appears. Open walk means terminal vertices are different. No edges repeats, then that's called trial. When a closed walk means end vertices are same and no edge appears, then it's called circuit. Then it's called circuit. Observe this very clearly. It is not a trial. He has taken the journey like this. Wait. So the concept will be very clear to you. Wait. Observe this very clearly. Okay. Starting journey from V1, E1 through V2, V2 to V5 through E3, and V5 to V2 again by E3, and E3, V3 to E2 to V3. I am starting a journey from V1 vertex and reaching V3 vertex where edge 3 counted twice. So edge 3 is repeated, it is not a trial. It is a walk, it is not a trial. Because I want to start V1 to V3, I am going to this, wait, I'll write it. I am going from like this, V1 to E1, V1 to E1, go to V2, V2 to V5, through E3. Again E3 to edge 3 to V2 is going back and V2 to edge 2 to V3. Okay. Where if you observe carefully in this walk what's happening? This walk, this edge is counted twice. So this is not a trial. In a walk, what I call open walk, edge counts more than once, it's not a trial. Edge is not repeating, then it is called trial. Edge should not repeat, that is the main thing. Edge should not repeat. If you observe this, I am making like this V1 to V5, I am traveling V5 to V2, V2 to V3, V3 to V5, V5 to E6. So it is a trial because it's an open walk, starts from here, ends with here, where no edge repeated twice. Okay, observe this carefully. He's writing first started from V1, okay, edge 4 through, he will reach V5, V5 to V2 through edge this, then V2 to, okay, V3, V3 to V5, V5 to, okay, like this way he is traveling. Okay, that is called trial because no edge repeated twice. Okay. Now come to the closed walk. Closed walk is nothing but starting vertices are same. Okay. If you observe this, I am starting a journey from vertex 1. Vertex 1, edge 1 through, I'll go to V2. Then I'll go to, okay, this V2 and again I come back to this again going. While edge is, no doubt it's a closed walk, but edge is repeated. So that edges are repeated, it is not a circuit. If you observe this, I am starting a journey from V1, V1 to V2, V2 to V4, V5, V5 to V3, V3 to V7, V7 to V5, V5 to V1. No edge is counted twice. Starting from V1, you observe this like this way I am going, starting from the same vertex and this is the same vertex. That's not nothing but what I call a closed walk. Closed walk with no edge repeats more than once. It's called a circuit. It's called a circuit. Then path. What is a path? A trial. Trial is clear to you. No edge repeated. In a trial, trial is nothing but where we call trial. Open walk, no edge repeats called trial. No, in a trial, no vertex appears more than one vertex, more than once or twice. Is called a path. Path is nothing but only, okay, no edge appears as well as no vertex should appear more than once. So, path is a trial. Trial is what? Open walk with no edge appears more than once. No vertex appears more than once is called path. Please observe, trial in which no vertex appears more than once is called a path. So in a circuit means internal vertexes, no internal vertex repeatedly occurs called cycle. But terminal vertices are same should be there for the cycles. Remember this, okay, observe this very clearly. Path is clear to you. Path is nothing but what he says. Try to understand that. Path is nothing but a trial. Trial is what? Open walk, no edge appears more than once. So path is nothing but a trial where no vertex appears more than once. Okay. This, if you observe, this is a path. Okay. Observe that V1 to wait. V1 to V2, V2 to V5, V5 to this. No edge appears twice, so it is called a trial. No vertex appears more than once, then it is called a path. This is a path from V1 to V4. First V1 vertex along with edge G1, you will go to V2, V2 along with edge 3, you will go to V5, V5 this edge will go to V3, this edge E7 will go to V4. This is a path from V1 to V4. Where if you observe that, V1 to V3, V3 to V2, V2 to V5, V5 to E5, again come to V5, V5 to V6. So V5 counts twice. Any vertex counts twice, it is not a path. Remember that. Where cycle, circuit concept cycle comes, cycle, is nothing but, remember, cycle, in which terminal vertex doesn't appear as internal vertex and no internal vertex repeated twice. No internal vertex repeated twice. If you observe this, V5, V5 to V2, V2 to V3, V3 to V5. No doubt it's a closed circuit. No doubt it's a cycle because no vertex appeared twice, no edge appeared twice. If you observe this, it's not a cycle because here, this to here, this to here, this to here, this to here, and comes to V5, V5 counted twice. Means no vertex count twice, it's not a cycle. Next one, trees and their properties. Next, what is a tree? What is a tree? That is the definition you should study. What is a tree? That's a definition. I am asking you about what is a tree. Graph is said to be tree if it is connected. If it is connected, means one vertex to another vertex, if you are able to travel in a graph, then it is called a tree, but it should not have, it has no cycles. It should not contain any cycles. So that, wait, it should not contain cycles. That's the main point. So next point, a tree has to be simple graph because loops and parallel edges forms a cycle. If it is a loop or if it's a parallel edges, it will make a cycle. So graph doesn't contain a, or what I call graph is a connected graph. It does not contain cycle. No doubt it should not contain a loop as well as it should not contain a parallel edges. Because if parallel edge is there, loop is there, it will make a cycle. Okay. You observe that each of these trees are called trees because there's a connected one vertex to another vertex. I can travel inside a graph where no what I call no cycle is there, or no parallel edge is there, no loop is there. So this is a cycle. One vertex from any vertex to any vertex I can travel. This is also a graph with tree because graph is